Good morning, all of you. My name is Ashutosh. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I am creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today we will going to start up a new module, that is your information theory. So in this particular lecture, we will try to get some introductory concept related to the information theory. So these are the outlines. We're going to start up with the introduction. Then we will going to discuss about what are various types of information sources. Then we actually try to quantify information, what basically the information is and how we're going to measure it. Then we will going to discuss some of the properties of logarithms. And finally, we're going to conclude by discussing some of the units of the information such as your nat, bits, etc. So, information theory, what is it and why do we really need to study of all those stuff? So, information theory is a branch of probability theory which may be applied to the study of the communication system that deals with the mathematical modeling along with the analysis of any communication system rather than with the physical sources and the physical channels. So, it means we just don't need to go through the physical systems and sources. With the help of this mathematical modeling, we can basically analyze the behavior of any system, such as its bit error rate, its capacity, etc. So information theory provides us a quantitative measure of information contained in the message signal. I mean, in this particular unit or module, we really have to study about that how we will going to quantify information, how we will going to measure it. Then only we are in a state to perform certain manipulation and calculation over that. So throughout this particular module, our whole agenda is just to find out what is information, how we are going to quantify it, and how we will going to analyze any communication system with the help of these basic introductory concept related to the information theory. So the two important elements presented in this theory are the binary sources and the binary symmetric channels. So since in this particular course we have to deal with this digital communication system, and in which specifically we are focused about your digital sources, more or less certain binary sources which will going to generate certain sort of digits, that is 0 and 1. So that is why our whole focus will be on our binary sources and binary symmetrical channel. So this is just a physical channel. Specifically, we should say that we have to model this particular physical medium in such an essence so that our bits 0 and 1 will going to pass through that, and we have to perform certain analytical behavior over certain mathematical modeling. So a binary source is a device that generates one of the two possible samples, that is 0 and 1. This is what I have mentioned at a given rate r, measured in symbols per second. So a binary source is obviously a device which will going to generate only two types of symbols, since it is a binary source. Either it is 0 and 1 with a rate of r symbols per second. So it means it will going to generate r zeros and ones, obviously the combination of zeros and 1 per second. So these symbols are called bits and are generated randomly. The information source will basically going to generate these symbols randomly. I mean, it is not necessarily, or it is not predictable that at what time it will going to generate 0 and at what time it will going to generate 1. So binary symmetric channel is a medium through which it is possible to transmit one symbol per time unit. So as we had already mentioned that it is binary symmetric channel, basically a modeling of a physical medium through which it is possible to transmit one symbols per unit time. However, this channel is not reliable and is characterized by the error probability P. Since channel is not reliable due to the impact of noise and several others impairment associated with the hardware. So channel is basically characterized by the error probability P, which is generally lying between 0 and half, and an output bit can be different from the corresponding input. But for what a reliable communication system is, we are in a state to always get the same amount of information or same amount of it that has been transmitted at the transmitting side. So information theory basically allows us to determine the capacity of the communication system to transfer this information source to the destination with full reliability. So information theory is obviously very fundamental to understand and characterizing the performance of any communication system. Obviously, we are talking about a digital communication system. So the information theory mainly deals with the three basic concepts, such as how we will going to describe the information sources, or you could say how we are going to model our information sources, how to represent the information generated by the source. Generally, source are generating specific sort of symbols which we have to convert them into the form of bits so that we could process them easily, obviously in the digital domain. And the third one is how we are going to transmit that information over the noisy channel so that we are in a state to predict the actual symbol or the signal or information that would have been transmitted at the transmitting side, obviously at the receiver. So now first we're going to start up with this information source. So what is this information source? Any source which will going to generate certain amount of information, that would have been considered as the information source. So it may be viewed as an object which produces an event, the outcome of which is selected at random according to the probability distribution. So the point is, here we're going to have a device which will going to generate certain symbols, but that generation of symbols is dependent, or we could say that it would have been modeled with the help of any probability distribution. So a set of source symbols is called the source alphabet, and the element of the set are called symbols or letters. So information source can be classified as having memory or being memoryless. So I mean, the information sources, the symbols they are generating, they would have been classified as your memory or being memoryless. Means if we are talking about our information source which is having memory, it means that the currently generated symbol would have been dependent upon previously generated symbols. And if we are considering it as a memoryless, so it means the currently generated symbol doesn't have any impact or doesn't have any relation with the past generated symbols. Fine. So a source with memory is one for which a current symbol depends upon the previous symbol. So this is what we had already explained. Then a memoryless source is one for which each symbol produced is independent of the previous symbols. So next one, a discrete memoryless source, which is one of the most important one, can be characterized by the list of symbols, the probability assignment of these symbols. Obviously, we are talking about the symbols it would have been generating is dependent upon certain probability distributions, and the specification of the rate of generating these symbols by the source. So this is the specific characteristics of any discrete memoryless source. So the classification of various information sources are given below, such as information source is broadly classified into two types, that is they are specifically generating analog information or they are generating discrete information. And again, since we are considering here digital information sources, so a discrete information sources again classified into two types, that is your discrete memoryless source, or you could say your DMS, as we have discussed in the previous slide, the basic definition of discrete memoryless source, what are they. And the second one is your stationary sources. So in stationary sources, what is the basic difference between your stationary sources and the discrete memoryless sources is stationary sources probability of generation of symbols will going to remain same with respect to time. I mean, it will not going to alter or change with respect to time. So next important question is, what is information? How we will going to quantify the information? That is, how we will going to measure that particular thing. So we will just going to convey some of the, we will going to present some of the statements, such as high probable events convey less information. As of now, just consider it as a statement, whereas low probable event has a large information associated with them. So let us understand with some example. What do you mean by that? I mean, here we are just trying to state that high probable event, that is the obvious events, obviously they will going to convey lesser amount of information. Suppose somebody is saying that sun will going to rise in the east, sun will always rise in the east, so there is not any information associated with this particular statement. But whereas if somebody says that tomorrow Pakistan will going to attack India and it will going to win that particular war, that is less likely event, or it is having very low probability, but again lots of information associated with it, such as how it will going to attack India and how it will going to win that particular war, since it is having very lesser number of resources in comparison to larger country India. So blah blah blah, I mean lots of information associated with that. So now let us understand with some other examples. consider the following forecast. Suppose Lucknow on 15th July at midday is a cloudy, and second one is Lucknow on 15th July at midday is a sunny. So here the forecast is an information source. Obviously the device which will going to perform this particular forecast, I'm talking about that. And the information has two outcomes, that is either cloudy and sunny. So I mean this particular statement is basically stating that on 15th of July what will be the weather in Lucknow. Either it is cloudy or sunny. So now consider the following forecast. Kanpur on 15th of May at midday will be cloudy, and Kanpur on 15th May at midday is sunny. So therefore this forecast is another information source. The information again will going to have two outcomes, that is either sunny or cloudy. Since we expect it to be sunny, the later outcome has little information since it is highly probable outcome. Conversely, the cloudy contains lots of information since it is highly improbable outcome. Generally we'll be facing certain sunny or a very hot weather in this May. So cloudy is a very improbable outcome. So obviously lots of information would have been associated with it. So a measure of the information contained in outcome and satisfying all the earlier properties were introduced by Hartley in 1927. So Hartley basically gives the definition of information, that is sometimes it would have been also being called as your self information contained in an outcome xi as I of xi is equal to log base to 1 over pi, that will be equal to minus log to pi. Conversely, if we could say that the previous properties that we have seen associated with the information, the only mathematical functions that follows is the logarithmic function. So this is the probable definition of any information. So self information, that is associated with the occurrence of event xi, that will be equal to log base to 1 over pi. So be cautious about this particular base. At in our upcoming slides we're going to discuss that what will be the base of that particular thing. But if we are trying to calculate the information in terms of bit, then that base should be equal to 2. So the definition or self information I of xi would have been given as minus log to pi. So this particular figure is basically showing the information against with the probability, or you could say that as the probability being increasing it out, the information associated with it, obviously it will going to get decreasing it out. So at low probable event we're going to have this high amount of information association, and with the high probable event we're going to have lesser amount of information, and finally for most certain event we'll be having this zero information. So the information content I of an outcome or the information symbol xi occurring with the probability pi must obey the following probability. Here we are just being considering any information source which will going to generate certain symbols x1, x2 or up to xn. Here xi is occurring with the probability, obviously its probability distribution is given as, or the probability associated with the occurrence of this particular symbol xi is equal to pi. It must have to obey these following probabilities. So information associated with that information source, that is I of xi, will always be greater than or equal to 0 for all values of pi's lying between 0 and 1. So since it is a probability, then it will always lying between 0 and 1. If probability of xi comma xj will be equal to pi times of pj, then I of xi comma xj will be equal to the summation of individual informations associated with that. So I of xi is a continuous function of pi lying between 0 and 1, and I of xi will always be greater than I of xj, obviously if these probability relations hold good, that is pi is greater than 0 and it is lesser than pj, and pj is lesser than or equal to 1. So if this particular probability equations hold good, then this must have to be followed. That so this is also holding that particular same scenario that we have discussed, that high probable event, obviously the probability of pj is higher than your pi, so high probability event will going to have lesser amount of information in comparison to low probable events. So these are the certain properties of logarithmic, that is log of b to the base a will be equal to c. It implies a to the power c will be equal to b. Log a to the base a will be equivalent to 1. Log x to the base a plus log y to the base a will be equivalent to the multiplication of these two. Then log of 1 of any base, that will be equal to 0. Log of x to the base a minus log of y to the base a, that will be equal to division. Derivative of log of x will be equal to 1 over x, and log x to the power n to the base a will be equal to n log a of x. This is just for the refreshment of your memory. You had already known all those stuff. So since we have to use them in our numerical analysis or in our upcoming lectures, so I'm just trying to convey these relationships with you, so that you get just brush up your old understanding. So derivative of log x to the base a with respect to dx, that will be equal to 1 upon x ln a. Log x to the power 1 upon q to the base a, that will be equal to 1 upon q log a x. Then similarly integration ln of x dx is equal to x ln x minus x plus constant term. Similarly, log x to the base a can be written as log x to the base b divided by log a to the base b. That will be equal to log x upon log a, or ln x upon ln a. Similarly, integration of log x to the base a dx will be equal to x ln x minus x upon ln a plus constant term. So we are mainly concerned about these specific properties specifically related to our information theory, but all these properties must be known to all of us. So now last topic of today's lecture is units of information. That is, we had already given what is the definition of information in terms of log function and the probability. So the choice of logarithmic base 2 and the arbitrary multiplicative constant of 1 simply gives the unit of information. In this case, the bit. As we had already mentioned that if we are taking the base 2, then the unit of that particular information, we're going to call it as a bit. Similarly, if we're going to choose a logarithmic base 10, then it will gives us the unit of Hartley. Obviously, we are talking about minus log of xi, and to the base 10, if you are taking base 10, then its unit will be equal to Hartley, and if it's base 2, then its unit will be called as your bit. And if we're going to choose the base of logarithmic as e, that is your natural logarithmic, then it will going to gives us the unit of nat. So Hartley measures and defines the information of a single outcome. We are interested in the information content of the source. So how we will going to get the information content of a source, we will going to discuss in our upcoming lectures, where we will going to find out the average information associated with any message or the information source. And when we're going to discuss this particular term entropy, we're going to get to know that how we will going to evaluate the information associated with the source or any single outcome. So hopefully you have got the basic foundation of information theory. In case of any doubt, you can ask me in the comment section. I'll try to solve them as soon as possible. So these are the references. Thank you very much for your patient hearing.